Hello everyone, my name is Julien Gamba and today I want to talk to you about pre-installed Android applications. I want to start with one number, 2.5 billion. That's the number of Android users as of last year, making Android the most used operating system in the world. Now the success of Android is due in part to its open source model. Basically anybody can grab the code, modify it to distinguish itself from the competition, then ship it on a device. Now in practice, this modification happen under the form of express system applications. And these system applications are interesting to study because since they are on the system partition of the device, which is read-only, they're considered to be privileged by the system. They can run in the background without user interaction, which is not always possible with user-installed applications, and they cannot easily be installed. As the system partition is read-only, you cannot just install it just like any other application. You have to root the device first, which is difficult for non-tech savvy users. Now, these extra applications can come from basically any actor of the supply chain. We can be very large. You have the chipset manufacturers, you have the phone vendors, network operators. All of these actors have at some point access to the device. They can add some more applications on the system partition. But all of these actors also have partners, and they can, as part of the partnership, allow the partners to install another system application on the device. And some of the partners have very data-oriented business models. Now, to protect users, Google developed a vendor certification, basically vetting brands. And the objective was to check the phones before they are sold to assess the security and privacy. Now, this is very good, but it's unclear what they're actually testing. There's not much information about it, and whatever they're doing is clearly not enough. This is just a bunch of examples of headlines from the past year of privacy and in some case security issues that happened because of pre-installed applications. So what we decided to do is to look into those applications to answer the following questions. Who pre-install applications on Android devices? What are these applications doing? And what can we do about it? Now, the first step here is to get access to the data. And it's not that easy because these applications in most cases are not available publicly. So you have to actually get the device, look for applications in the system partition, and extract them from there. So obviously we cannot buy all the devices from all the brands from all the different countries. That's just impossible. So what we decided to do is to follow a crowdsourcing approach. We developed an app, Firmware Scanner, which is freely available on Google Play. And when you install it, it scans your system partition and look for applications that we don't already have on the server. And then uploads these applications to our machine so we can analyze them. Now, of course, we don't get any personal data and nothing is uploaded without user consent. So this was quite successful because we were able to access almost 82,000 unique applications from more than 200 different vendors. So we cover a lot of vendors, obviously the most common ones such as Samsung or Huawei, but also a lot of lesser known vendors that may be available only in some countries or some regions of the world, which is very interesting. Now with this data set, we are able to answer the first question that we wanted to ask, is the supply chain analysis. Who is actually putting applications on devices? And to identify developers, basically what you usually do in Android is to look at the certificates. Android requires applications to be signed with a certificate, so you can look at the issuer or the subject field and infer from that, right? And this is an example of a Google app. I assume it's a Google app because the certificate says it's Google and the package name as well. Problem with this certificate is that it's not like on the internet where you can go up the chain up to a root and then validate all these steps and be sure that the certificate you have is actually issued for Google. And in Android, it's all self-sign. So you can end up with this application, which is now some blue reward. It's actually found on a blue phone, and it's also signed by Google. At least the certificate claims to be from Google. And this is a huge problem right off the bat. There is no way, given these two applications, to know which one is actually signed by Google, which certificate is actually the right one. And in fact, in a whole dataset, we found more than 90 unique certificates supposedly from Google, and we have no way of knowing which one are real. I mean, I assume some of them are real, of course, because Google does provide some applications, but there's nothing preventing me from creating a Google certificate, signing my malware application with it, and then ship it on a device if I have the possibility to do so. So we found lots of certificates from, of course, from vendors, which makes sense. Those are the ones that provide the applications on the devices, but also from non-vendors, not phone vendors, companies such as MediaTek. And MediaTek in a way makes sense because it's a chipset manufacturer. So maybe they provide some software to interact with the hardware that they sell to phone vendors. But we found also companies such as Verizon. For some reason, we found like more than 10 certificates that claim to belong to Verizon signing pre-installed application, and I'm not sure why we need this. And in some other worst cases, we're not even able to identify the company. In some cases, we just have the country code in the issuer field, or sometimes we have actually a known company or even nothing at all. And in short, there's just no reliable way to identify the developer and application. Given a pre-installed application, we have no public profile of the app. We have no market metadata. Just with a certificate, we have just no way of identifying the company that developed the app and put it on the phone. Now, another way of identifying actors of the supply chain is third-party libraries. So we looked at the presence of third-party libraries in the pre-installed application, and we focus on advertisement, analytics, and social networks because these can put the privacy of users at risk. And we found hundreds of such libraries in pre-installed applications covering thousands of apps. And the problem is that there is basically no user consent. You have a phone that you just bought, there is an app that somebody put there, this application embeds the Facebook SDK, and all of a sudden some data is going back to Facebook, and at no point did they ask you for consent. At no point did you agree, okay, yes, I want the Facebook SDK in this app. And more than that, there's not much you can do. If you're able to root the phone and remove the app, good for you, but maybe this app is actually needed for the phone, and you cannot just remove it without breaking your phone, making it useless. Now, this is already bad, but the second question we wanted to answer is, what are these applications actually doing? So first, for this, I need to quickly explain to you the Android permission model, as I'm not sure everybody's familiar with it. So in Android, some resources such as the microphone, the contact, the location are protected from applications, and if they want to access it, they need to request the permission. And in the case of dangerous permissions, such as the location, for instance, the user need to grant the consent to the application. Now, what developer can also do is make available some of their functionality in the apps to other applications on the device. And if they do this, they can create the custom permission to filter out who gets access to that functionality or not. Now, we looked at those custom permissions in pre-installed application, and we found almost 5,000 unique custom permissions. And there's little or to no documentation at all. We don't know what they are protecting. In some cases, such as the one on the top line, the Baidu location service, we can probably assume that it has something to do with location, but we don't actually know. It could be something else. There is no rule as to how you can name your custom permission, so you can put whatever you want. Now, we were still able to attribute the majority of these permissions to phone vendors, which makes sense again, because as a vendor, you may want to provide new functionality for developers and for users, and that can happen through custom permission. But almost 10% of this permission we're not able to attribute to any company at all, because it's impossible to find like the name of the company on Google, or it's just some small developer that is contracted by another bigger company, or in those cases we don't know what is protecting, and we don't know who is putting in there. Now, some of these permission are not only on extra applications but also on core Android component, meaning that in some cases the core Android component, so the part of the Android source code that is publicly available, has been modified to provide some new API, new functionality for other application on a device, and it's protected by custom permission. In a lot of those cases, we don't know who is actually providing the custom permission. Now, using this permission, we can also highlight some partnerships between companies, because if you always find, say, on a Samsung device, some Facebook permission, then maybe you can infer that there is some kind of partnership between the two companies. And actually, if you look at this heat map, and especially these two lines, the top line is MediaTek. Again, it makes sense that MediaTek has a lot of custom permission because it's a chipset manufacturer. They provide hardware, they provide the software that goes with it, and you have to be able to use it at some point. But the bottom line is Facebook. Facebook has custom permission present in a lot of vendors, including major vendors such as Samsung. And speaking of Samsung, if you look at the other dimension, Samsung has many custom permission with many different companies. And it makes sense for a third-party company to contact Samsung. If you want to touch a lot of users easily, you just strike a partnership with Samsung, and then all of a sudden you have thousands, if not millions of users as just there for you. Now, what we did also is applied static analysis on a random subset of our apps, just to understand what kind of PII or personal information they could potentially access. So many of these applications could access dangerous PII, such as the IMEI, which is a unique non-resetable ID, or even access the device logs. So I'm not going to go too much into details into this. I encourage you to read the paper if you're interested, but the takeaway here is that lots of these applications have actually code that allow them, if they wish to access such dangerous PII. We have not run dynamic analysis on those, so we don't actually know if they access said PII and then exfiltrate it somewhere. We don't know that, but we know that potentially they can. The code is there to allow them to do this. And we also identified some known malware samples such as Triada or root